Welcome back to our last algebra skills. This time we'll be talking about compositions of functions and how that's used to calculate the inverses of functions. Often, we're dealing with multiple different functions where the output of one function becomes the input of another. For example, we could have one function that takes in the number of hours we work and spits out the amount of money that we earned. And then we could have a second completely different function that takes in how much money we have and outputs how many pizzas we could buy. And we could create a new function that goes directly from hours worked to pizzas bought. And the way that we're going to do that is using a technique called function composition. Let's say we have two functions, one of them that tells us how much money we have, and one of them that tells us how many pizzas we can get. What we can do is we can calculate f of x first, and then whatever the output of that function is, plug it into g of x. The notation of this is pronounced g of f, in this case g of f of x, or equivalently g composed with f. And that is where we take the function f of x and plug it directly into g. As you can see, we're putting the entire function f inside of g. Now, the order that we do this matters. And in general, finding f of g of x and finding g of f of x are going to be two different things. Let's look at two examples here, where f of x equals 3x minus 1 and g of x equals 2 minus x. Let's start with f of g of x. We know that g of x is the function 2 minus x. And so f of g of x is f of 2 minus x. We just took this g of x and replaced it with what g of x is equal to. Now we have to look at what f does. F of x is the function 3x minus 1. It takes an input x, triples it, and then subtracts 1. And so if we're doing f of 2 minus x, our input is now 2 minus x. So we're going to take our input, which is 2 minus x, we're going to triple it, and then subtract 1. If we want, we can simplify this, giving us 6 minus 3x minus 1, and then we could rewrite that as negative 3x plus 5 if we wanted to. And this is our function composition. This is what f of g of x was equal to. Now, let's look at g of f of x. This is going to be the exact same idea, but this time we're going to plug the function 3x minus 1 into g. So instead of g of f of x, we're going to write g of 3x minus 1, and then we're going to evaluate the function g at the input 3x minus 1. In order to do this, I like to think, what does g do? Is it takes our input x and then subtracts it from 2. So we have 2 minus whatever our input value is. In this case, our input value is 3x minus 1. So we're going to write 2 minus 3x minus 1. This gives us 2 minus 3x plus 1, or equivalently, negative 3x plus 3. Notice that these are not the same function in general. And so that means that in general, g of f of x is not equal to f of g of x. Although there are certain situations where they are the same. In general, they're going to be different.